Hello, David Snowpick here from Snowpick Games, and this is my 8th devlog about WebXR support in the Godot game engine. It has been 1 year since my last update. I am really sorry about that. Look at this, January 19th, 2021. I didn't end up working on WebXR as much as I had planned in 2021. 2021 just did not go according to plan at all. But I finally have something to report that is devlog worthy. By the way, I'm going to call these devlogs now. Progress report kind of implies that we're working toward a specific end goal, but now we're just kind of improving WebXR forever, so devlog. But the big news is that in Godot 3.5, starting with 3.5 beta 2, which isn't out yet, you'll be able to easily put UI controls on the screen for smartphone AR apps in WebXR. Previously, if you had put a canvas layer with some controls on it, the controls wouldn't actually appear and everything would become semi-transparent. So this is what it looks like without any controls. You can see in the background the window in my office, and then down here is some 3D geometry of a racetrack that's being rendered in Godot. And if you put a control on here, what I'm trying to do is just put a button in the upper left-hand corner. So you see here there's a canvas layer with a button on it, just a button in the top left corner. You won't see the button, there's nothing in the top left corner, and this 3D geometry suddenly becomes semi-transparent, and you can see my keyboard underneath it. So I was aware of this problem for at least a year, but I had thought that 1, it didn't matter, and 2, that it was unfixable. Now, the reason I thought it didn't matter was I thought that you were supposed to create UIs for AR apps the way that you do for VR apps, which is that you put the controls on a secondary viewport that you render as a texture onto a mesh in the 3D world. For example, in this demo, I have this FPS monitor in the background and actually renders like a cool little chart. But this is just a 2D canvas rendered to a texture that's put on this mesh in the world. And this is the right way to do it for VR and for stereoscopic AR glasses, and I thought it was also the thing to do for smartphone AR. However, Sergio Silva contacted me and convinced me that for smartphone AR, you should be able to just put a canvas layer with some controls on it. He pointed out that it worked when using Godot with ARKit or ARCore. But also, I had thought it was impossible to fix because I had thought that Godot was purposefully hiding controls when the viewport was put into AR/VR mode. However, I chatted with Bastian Oli, the AR/VR maintainer for Godot, and he told me that it wasn't really on purpose, but just like a technical artifact of the way that the Godot renderer worked with AR/VR interfaces that render to external textures. If the AR/VR interface uses the textures provided by Godot, then the controls should render fine, which is what ARKit and ARCore are doing. So I had implemented the WebXR interface in Godot to use external textures for a combination of silly reasons. So WebXR gives us an OpenGL frame buffer to render to, but Godot wants you to give it a texture, not a frame buffer. So we were giving it a texture and then copying from the texture to the WebXR frame buffer, which is a serious performance problem on mobile, and I had it in my head that I was going to hack the Godot renderer to allow me to give it a frame buffer instead, but I never got around to doing that, and there was really no reason that we couldn't use the textures created by Godot rather than the external ones. We could just as easily copy from Godot's textures to the WebXR frame buffer. That doesn't solve the performance problem, but it doesn't make it any worse either. So we started hacking on that in Game Dev stream number 34. By the way, I stream Game Dev almost every Friday. You should come hang out. It's fun. So we started working on this on stream, and huzzah! The controls will now render. So where is that picture? This one. So now the control is rendering up here in the upper left-hand corner. Everything is still semi-transparent, and it turns out that you can't actually interact with the button. And just tap it on this button, forever, and nothing happens. But this was an improvement nonetheless, so I made a PR. This PR, switch WebXR interface from using external textures to using the render targets from Godot, and it got merged. Then dpanther, who maintains the Unity WebXR integration, watched my stream number 34, and explained to me on the WebXR Discord how screen input is supposed to work in WebXR. And it's really strange, truly weird. Touching the screen triggers a WebXR select event. That's not weird. And the input source for this event has a gamepad attached to it. Not all input sources have associated gamepads. It's like an optional thing, but these ones do. And it has a joystick with 2 axes that represent the X and Y position of the touch, except since they are joysticks, they are floating point values from -1 to +1, and you have to convert them proportionally into the pixel value. So it's like this. You know, you get a Y value that's from -1 to +1, and X value from -1 to +1. Weird, right? And also, I found just no information in any of the WebXR related specs that actually lay this out. I could maybe have missed it. There's a whole bunch of different specs that together make up WebXR, but I didn't see it anywhere. I asked dpanther, and he says someone on the Chrome team explained this to him. So anyway, on stream number 37, we started to implement this, taking these select events and converting them into touch and drag events and pushing them into Godot's event system. And then you could actually interact with the controls. You could press the button and have it do something. But everything was still semi-transparent. Whatever, this is still an improvement. So I made another PR, this one, that got merged. So we had one problem that turned into 3 problems. We fixed 2 of them, but 1 still remains. So I was thinking about the semi-transparent issue. And someone, I think Sergio, had mentioned that it looked like some sort of additive render thing. And yeah, it does look like that. Because if you see the black or the almost black, if there was something fully black, it would appear fully transparent. The whites are fully opaque, and all of the colors in between are somewhere in between, right? And black is represented as 0, 0, 0 for the red, green, and blue components. And if you added that to the pixel underneath, it would be transparent. It just wouldn't be there, right? I'm not super experienced with rendering. It's one of my weakest areas, but I did some Googling, some docs reading, and I found that you control blending in OpenGL with a set of functions. These blend equation separate, blend func separate functions. And I spent some time learning more about those, thinking through like what blend mode settings appear to be happening, what settings we would actually need, and then I went looking through the Godot source code for all the uses of those functions. And I found that it would use different settings if you set the render target as transparent. I followed this up into the viewport node and found that there's this property transparent_bg that if you set it to true, it flags the render target as transparent, which changes these blend changes these blend functions, such as glblendfunc, to have different settings. And lo and behold, if you go and set that value, like here, to true, then suddenly the semi-transparent thing is gone. Go to my final screenshot here. You can see the real world in the background from the camera, the 3D geometry fully opaque, and the button fully opaque, which you can actually interact with. So I think what was happening is that the canvas layer was being rendered onto the 3D stuff, and it was blending incorrectly because we were setting a transparent clear color, since we don't want to completely obscure the image from the camera. And if we were rendering without a canvas layer, all was good. But as soon as we did, everything got messed up. I think not correctly blending the transparent on the canvas layer with the transparent that's already on the texture. In any case, no PR was necessary. Folks just need to know for smartphone AR, they need to add this one line of code. Eventually, I'm going to make an AR tutorial. So anyway, now everything is fixed. Serio's problem is solved. And starting in Godot 3.5 Beta 2, any game developer can create a smartphone AR app for WebXR and easily put working UI controls on it. This opens up the possibility of apps that weren't easily doable before with Godot, and I'm super excited to see what folks create. Anyway, that's all I've got for you today. Thanks for watching. Bye-bye.